Hi everyone, Roman Kozak here. I'm back with a monthly video series. It's a weekend project where we're going to design a product and take it all the way from idea to first prototype, whether that's virtual or physical. And we'll be using tools like Altium Designer, which has a very nice integration into Solidworks. So we really will be able to design the full product virtually. And if we have time, we'll also build it using things like a 3D printer and a new pick and place machine I just got. As my full-time job, I'm engineer and co-founder of an agriculture technology startup called Verity. We build hardware and software for farms. You can check out our link in the description. For this first video, I want to take a look at this guy here. I think we all know what it is. It's a portable battery bank. That's quite useful since we all have electronics that we need to charge on the go. But they can be quite expensive if you just take a look on Amazon, and they don't have all the features that I want. I've always wanted one of these with USB Type-C ports. So I think in my product, I'm going to add USB Type-C ports. And I think I can make it look a lot better. So let's see what we can do. Now, before I show you the schematic in Altium, let me give you a quick overview. So inside of our portable battery bank, we know that we're going to have a battery. And let's just say it's 2500 milliamps. Enough to charge most phones once. We also need a way to physically charge this battery. So let's add a USB-C input. And that's going to accept 5 volts. But we can't simply plug our USB wall charger into the battery. Things would explode, it wouldn't work. So instead, we're going to use an integrated circuit to help charge this battery. And this integrated circuit is called a LiPo-ion charge controller. And now we can charge the battery. But we can't simply plug our phone or device that we want to charge from the portable battery bank into the battery. The voltages don't match. This phone requires 5 volts, but this battery has a voltage that ranges from 3.7 to 4.2 volts. So plugging this phone into this battery would do nothing. So in order to stabilize and step up this voltage, we're going to need a little bit more circuitry. We'll use another integrated circuit called a DC to DC step-up boost converter. And the voltage coming off of this DC to DC step-up converter is a nice stable 5 volts. So with one last USB-C output, we can finally charge our phone. Now let's build this in Altium. So here we are in Altium Designer 21. It's their newest release and has a lot of awesome new features. There are 3 features in particular that I want to talk about today. One is how easy it makes to select parts and components for your project. Figuring out what parts to use is often a time-consuming process. You have to think about where to get them, and you have to be certain that they're going to be in stock for the life cycle of your product. The second feature I'd like to talk about is the built-in collaboration and version control in Altium. It makes it very easy to have a history of all changes that you've made to your project, as well as share those changes and get feedback and comments from others. The third feature I'd like to talk about is Altium's integration with Solidworks through their MacLeod co-designer. But before we get to that, let me just quickly run over our schematic for our battery bank here. So as you can see, I have 2 schematic sheets. The first one here is for the charge controller. and here I have my charge controller IC. It's connected to the battery on the output and my USB Type-C device on the input. I also have an LED here to indicate that it's charging, as well as a filtering capacitor. And I've also assigned a net class to the power nets here so that I know when I go and lay out this board that they'll require a wider trace. In my second schematic document, I have my second IC. This is the DC to DC step-up converter. It's connected to the battery via this port, which links it to the previous schematic. And it's connected to the USB Type-C output here. I also have filtering capacitors, an LED to indicate that I am sending power to the USB Type-C device, a voltage divider here to set the output voltage of the DC to DC step-up converter. And an interesting thing to note here with these 4 resistors, this is specifically for charging iOS devices, which require specific resistors on the data ports. Now, like I was saying before, that first feature that I like most about Altium is it makes selecting components and adding those components to your schematic super easy. So I've just created a new schematic here to show it off. Let's open the manufacturer part search. Now, if I'm looking for a component, I can simply click in here through integrated circuit and then go through all of their submenus, as you can see here. Or if I know the exact component that I'm looking for, I can simply enter it in the search here. So let's enter in a popular microcontroller, the STM32L0. Here we can see a list of all the different variations of the STM32L0, as well as where it is in stock and the price. So if I click on this second component here, I can see that it has stock available immediately from these suppliers. Something that I love about the manufacturer part search is the models that are directly available to be added to your board. I don't need to go to SnapEDA or Ultra Librarian, download the zip, and then add it to my libraries folder. I can simply drag and drop this part or click place directly into my schematic, just as easy as that. Now, if I have a specific standard that I want to make sure that this footprint meets, then I can simply download this, customize it, and then add it to my schematic. Comparing parts is also very easy. I can just hold the shift button down as I select two components, and we can see that they're being compared side by side. Now, once you've selected all your components, just like I have in my battery bank, you can go over here to your active BOM document. And I can see all of my selected components. Now, Altium does have an integration with Octopart as well as IHS supply chain. And IHS is the world's leader in supply chain and manufacturer lifecycle data. So as you can see here, it's validated whether my part is suitable for volume production. And you can see these two parts here are not recommended for volume production. Now, I'm currently subscribed to the Altium Standard license, but if you have the Altium Pro license, IHS and Altium will actually recommend drop-in replacements for the parts not recommended for volume production. So it would be just as easy as right-clicking and adding that alternative part into your BOM. And now you can be confident that when you manufacture your board at volume, you're not going to run into supply chain issues. Okay, let's step over to the board now. This is my board for the battery bank. As you can see, I have those two USB-C ports, one for input, one for output. I have a power slide switch, the connector for the battery. Here I have my DC to DC step-up converter and the LiPo battery charger, as well as my 2 indicator LEDs. Now let's talk about Altium's collaboration features. As you can see, I have my Altium 365 workspace connected here, and I can access it by simply clicking this link. And what Altium 365 is it's a web viewer for your Altium files on steroids that makes it very easy to share your project with others and receive feedback. So for example, if I shared the link to my project with someone else, they would see this view. They can see my 2 schematics, and they can even go ahead and add comments into my schematic. Whatever that comment might be, and they would just click post and then I would see it. They can also view my PCB, add comments of course to the PCB, or double click on any trace to see where it exists on the board. They could also search for a specific component and see it on the board. They could take a look at my board in 3D. Or even take a look at the BOM. And we also have another tab here for supply, where they're going to get a little bit more insight into the supplier for the parts on my board. So it's very useful for working with others and receiving feedback on your board design. As well, it just has that built-in version control, as you can see here. So these are all the pushes that I have made into Altium 365. And you can see all the changes, and of course I can go back to a previous version. So let's jump back into Altium. The last feature I want to talk about is MCAD Co-Designer. So of course, when you're designing a product, you have your circuit board, but that circuit board often has to live inside of an enclosure. And you'll likely have to, in other PCB design suites, you'll likely have to go File, Export, and export your 3D step file for your PCB. But with Altium, you can actually use their MCAD Co-Designer feature here. So with this, I can simply click push, add a comment, and post this new revised step file into Solidworks. Now let's see how that works on the Solidworks side. So we just pushed the most recent 3D CAD file from Altium into Solidworks. So now in Solidworks, with my Altium Co-Designer add-in installed, I can simply click the pull button to pull changes from Altium. And I can see the changes here, choose which ones to accept, and then click apply. And then my PCB here will update in place, and I can make the appropriate changes and adjustments to my enclosure to match those changes. I can verify that the board height is still correct, that the LEDs are placed in the correct location for pass-throughs, and that my USB ports are still lined up and looking good. If I have an enclosure already designed, you can start the PCB design process in Solidworks. So through Solidworks, you can specify the board shape with its appropriate cutouts such as mounting holes. And then you can push that using this button here to Altium Designer. And then your electrical engineer, she can go ahead and use your board shape that you just pushed when she's laying out components. All right, guys, here's the portable battery bank that we designed using Altium and Solidworks. You can see that I have the 2 USB Type-C ports, I have a power switch, and of course I can add other things like pass-throughs for those LEDs. My next steps are to 3D print this enclosure and then get the PCB manufactured by JLC PCB, and then we can use our pick and place machine to place these components, and I'll make another video on that next month. The purpose of this video was just to show you some of the new features in Altium Designer 21 that make designing products like this a lot easier. I know this video was far from complete and I missed out on a lot of points that I would have liked to address, but hopefully we can cover those in future weekend builds. But for now, I'm excited to continue using Altium to design more products, and I don't know what I'm designing next month, but I want you there to see, so please consider subscribing. I've also left links to try out Altium for yourself in the description. If you're a student, just know that they have a free 6-month free trial that's super easy to sign up for. So thank you for watching, and we'll see you soon.